Hello, everybody, and I hope you're just joining me from question number 3. Question 3 stated very boring. I mean, it was a perfectly competent question, but we could see from question number 3, question 4 coming up, and it starts with a historian, or if you're, really fancy, an historian or an historian, depending on how you pronounce your H's and what part of England you're from. But I want to know what this historian's doing, because compared to the boilerplate, almost textbook question that was 3, question 4 looks very interesting to me. So what's going on with this historian? A historian divides the past 2013 years into 63 time intervals, each containing a positive integer number of years. Explain why 2 of these intervals must have the same length. Okay. So at first glance, I'm thinking pigeonhole principle, but then again, we're not trying to show that, 2 things must fit into a number of time intervals. So what could we do here? Well, suppose that no 2 had the same length. That's, let's try for a proof by contradiction. Suppose that no 2 have the same length. Let A1, A2, all the way up to A63. Maybe I should have used L, but I don't want to use the curly L. Let B be the lengths in increasing order. Okay, it's less than, not less than or equal, because we supposed that no 2 have the same length. Well, then we see A1 plus A2. I mean, it has to add up to 2013, because the historian is dividing the past 2013 years into 63 time intervals, so they do have to all add up to 2013 years. Now, I have no idea what these intervals are, but the smallest they could be is A1 is 1, A2 is 2, A3 is 3. So, I will make a blanket statement. Notice that AI has to be greater than or equal to I. And if we wanted to, we could prove this by induction. A1 has to be greater than or equal to 1. Why? Because it has to have a positive integer number. And A2 is at least A1 plus 1, which is at least 1 plus 1, which is 2. And in general, AN plus 1 is at least AN plus 1, which is at least N plus 1. So that's a very quick, you could do a longer proof by induction, but it's question 4. Don't waste your time. There are bigger fish to fry on this contest. This statement, I think, would stand, but a quick explanation wouldn't go amiss. Even a quick example of showing that A2 must be at least 2 would probably do. So, then 1 plus 2 plus all the way up to 63 must be less than or equal to A1 plus A2 all the way up to 63. And I'm betting that the sum of the first 63 natural numbers is bigger than 2013, because then we'd have a contradiction. So, formula for the sum of the first k natural numbers, by the way, if you don't know it, is k times k plus 1 all over 2. So it's a useful formula to know. It popped up on this contest. It pops up on contests every now and again. So that means this is 63 times 64 all over 2. But that's 63 times 32. I have no idea what that is off the top of my head, so we'll just multiply it out. 63, 32. 126, 0, and then a 9 and a 1, 8. So that's going to be 6, 1, carry the 1. So 2016. So that tells me 2016 is less than or equal to 2013. And that is crazy. Or more accurately, we say this is a contradiction. This is an impossibility, so we might have assumed something wrong to start off with. And indeed we did. Suppose that no two have the same length, so therefore at least two must share a length. Because if they didn't, just that assumption alone gave us something that was utter nonsense. Okay, that's how a proof by contradiction works. So that was 4A. 4B, also a word problem apparently. Consider the following game of dice. Player A rolls a standard die, 1, 2, 3, 4, 5, 6. Player B rolls a modified die with faces 3, 4, 5, 6, 7, 8. With what exact probability will player B roll the higher value? So, we've got 36 outcomes. You know, we could list the thing that player A rolls and the thing that player B rolls. So we could have 1 and 3, or we could have 2 and 3, or player A could roll 3 and B could roll 3, and we could list them all out. There's 36 of them. But I think an easier way to do this question would probably just make a very quick chart. So A rolls a 1, a 2, a 3, a 4, a 5, or a 6. By the way, we'll point out there's 36 outcomes. And so when we do our probability, it'll be something out of 36. Now up here we'll have B rolls. So B rolls a 3, a 4, a 5, a 6, a 7, or an 8. And I'm just going to put a check if B would win. So check equals B wins. Check mark. So B rolls a 3, A rolls a 1. Of course he'll win. Of course he'll win. Now it's B rolled a higher value. So you know, if they both roll 3, that's not a higher value. Okay. What if we have a 4? Well, he'll beat A rolling a 1, 2, or a 3, but not a 4, 5, or 6. If he rolls a 5, he'll beat everything up to a 4. If he rolls a 6, he'll beat everything up to a 5. And if he rolls a 7 or an 8, he will beat everything. Okay. And A will lose except in these 10 cases where B rolls too low. And that means that we have 26 up here. Sometimes it's easier to count the misses than the hits, because we know we have to have a total of 36. So 26 where B rolls higher. Not equal, higher. So our probability is just going to be the number of outcomes that we do want, 26 of them, out of the total number of outcomes, 36. And we can simplify that to 13 out of 18. So that's going to be our probability. Very quick chart. As long as you explain the setup of the chart, I think this one's straightforward and you'll get full marks. All right, so our next question will be question number 5. Join me for that in the next video if you would like to. Feel free to like or subscribe, do any of those sorts of things. And if you just want to jump ahead, I will see you later on down the Manitoba Math Contest. Have a wonderful day.